So up to this point, we've talked about Lewis dot structures in terms of neutral covalent compounds. So everybody's sharing electrons, everybody has access to them, but the one thing that we haven't really discussed is this idea of polyatomic ions. So up to this point, we've had polyatomic ions, and they look kind of like this. Where we know we have this ion, but this ion is really a group of atoms that carries a singular charge. But the one fundamental question is, why does this happen? Why does this form? To get at this central idea, we have to understand that this all is bonded together, and there's some bonds that are happening within our polyatomic ion. So in this case, we have nitrogen bonded down to 3 oxygen, but what does that look like? What does that really mean? So we know that there are 2 nonmetals coming together, so we have a covalent bond forming between them. So we can draw a covalent Lewis dot structure for something like nitrate, NO3 with that -1 charge. So our least electronegative element still goes in the center, so that's nitrogen. And we're going to surround it with our 3 oxygens. Everybody gets a single bond, and now we have to make sure everybody has access to 8. So currently as it sits, this oxygen has access to 2, needs to have access to 8, so we'll give it 6 more. This nitrogen has access to 2, 4, 6, it should get access to 2 more. This oxygen has access to 2, should get 6 more. Same thing up here, this oxygen has access to 2, needs access to 8, everybody now has a complete octet. Let's see how we did. In our drawing right here, we know that from past experience that it should depict exactly how many valence electrons we have. So if we're adding them all up, nitrogen has 5 valence electrons. Oxygen each has 6 valence electrons. There are 3 of them. So for a grand total of 6, 12, 18, we should have 23 electrons shown or depicted in our drawing here. So let's see how we did. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this one doesn't work, but we know from past experience that in order to make it work, we have to redraw it. So if we're redrawing it, we know that we have to add a double bond somewhere. So let's add a double bond here, and let's clean up some of our electrons now. So I added a double bond here. Right now as it sits, oxygen has access to 2, 4, 6, 8, 10. So we need to get rid of that one because now it has access to too many. Looking at this nitrogen has access to 2, 4, 6, 8, 10, too many. Over here, oxygen has access to 2, 4, 6, 8, 2, 4, 6, 8. So now everybody has access to 8. Everybody wins. Let's see how this one works. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24 is pretty close to 28, or 23 rather. So these are pretty similar to one another. But we also know that there's not necessarily that one extra electron that we have access to. So somebody has to have one less electron. Somebody has to not be happy. For us right now, let's say that this oxygen over here actually doesn't have a pair there. So now we have this lone electron, which means that we now have 23 valence electrons. Yay, everybody wins. So right now as it sits, remember that this has 23 valence electrons. We also know from past experience that this isn't stable though. Not everybody has a complete octet. Specifically, this oxygen is missing an electron to make it have a content or complete octet. So this one's not happy. In order to make it happy, it needs to gain one more electron from somewhere. So if we had something like this floating around and there happened to be somebody like lithium passing by, lithium has 1 valence electron. In this scenario, lithium could donate this electron, and we could form a bond between this whole thing. This is where that -1 charge on nitrate comes from, because in order for this to be happy, really it needs to gain 1 more electron. If it gains 1 more electron, it would be happy. So if lithium donates this 1 electron, now this is content. Lithium's content, everybody wins, and now we have an ionic bond forming to something that's covalently bonded within its structure. And this is really why when we depict nitrate, it always has NO3 and carries a -1 charge. Because if it didn't carry that -1 charge, it wouldn't be stable, wouldn't be content. So it needs to be able to pull that 1 electron from somewhere in order for our covalent dot structure to be complete and everybody to have access to a full octet.